Good morning and good afternoon. This is episode 3 of Coffee and Compressed Air, and this week we will be focusing on air quality. If you caught us last week, you saw that we spoke with Martin Zeller, who was speaking on the sensors, and we dove into a little bit on when the sensor picks something up, now what? So it's a perfect segue into this week with Mirko here. And I will let him do a quick intro and get started because, as we all know, this 20 minutes goes very fast and we want to respect everyone's time and work. So, Mirko, I will send it over to you.
Thank you, Dani. Good morning, everybody. My name is Mirko. I'm the president of C&CA Technologies in North America. We're an independent manufacturer of compressed air treatment. So we actually make sure that Martin get right air quality readings out of his equipment. The end user and all the quality departments are satisfied, and if we can save and not worry about any contamination.
Perfect. So I kind of just jump in because, like I said, we don't have so much time.
Yeah.
Is your basics. So I know nothing about filtration, kind of what you do. I know that there can be risks that Martin touched on last week. So risks of contaminants getting into food and beverage or even auto manufacturing with the paint. So he spoke about how to identify if it's getting through. And now we speak to you, which is, okay, seeing through, what's the first step? Kind of through your process, how you can help them start to manage some of those risks.
Sure. I would like to start at the real beginning. So when you set up a compressed air system or you're expanding a compressed air system, it's already like one of the first steps should be to focus on what should my air quality at the end be? What do I need for my application? And that really depends on kind of application do I have. You already talked about food, beverage production, but also general manufacturing. If you're running a CNC machine and the head is turning at 20,000 RPM, you don't want any particles in there that would cause additional wear, would maybe cause the machine to break, and then you have downtime. So it's not only the production where it's very visible, like we'll know the news recalls food manufacturers, but it's also breakdowns of equipment, also just protecting your equipment and protecting your efficiency. So important to focus on what air quality do I really need. It's really simple for us to overdo it also. So we don't need to have a small tire shop or a car body shop like the most sophisticated treatment. So we want to air as good as needed, but not as good as possible, right?
Okay.
That also like keeps the efficiency of the system intact.
Okay.
We have a couple of steps, followed the Martin's approach a little bit. So the different steps that we would recommend going through when you either get bad readings out of the system or you're just setting up or expanding your current plant. Step, of course, understand the application. Air quality do I need? Is the demand profile? How many shifts do I run? That will like influence the type of equipment that you would choose. Going to be the air pressure, what I would do my end application, my machine, my user, my consumer, what does that need, what pressure level, how much flow. Then maybe in your plant you have different sections. So maybe you have a really quality air demand, but the rest of the plant is just like general low guns and your nozzles. So that could also be a solution to set up two different systems or to treat the air and boost the air quality for that particular application. Then we would recommend taking the ISO 8573-1 quality classes as a baseline and try to classify what quality do you need at each consumer, and then you can dial in basically on what will be the overall layout and what will be the demand for equipment, for compressed air treatment equipment in my plant. Once you have that dialed in, you want to have at the end. So then it's time to choose the right equipment type. So usually the ISO 8573 has 3 different contaminations, main contaminations. That's water, moisture, particles, and oil. So we usually start with the water. So we choose the right dryer for that application. Normally, like the 85-90% of systems run well with a refrigerated dryer. But if you're really in a high quality, in a critical environment, you might need a desiccant dryer. Depending on the size of the system, on the volume flow, it makes sense to go heat regenerated or to use a heatless regenerated system. certain applications where it all makes sense to use a membrane dryer that will also reduce the humidity. That is really special applications in mobile or in roof areas. So that's where the system also could come in. And then again, there, as I said before, there can be also combinations. So maybe you put a central treatment station with a refrigerated dryer, and then you have one point of use where you need super dry air. So you use either a membrane dryer to lower the dew point even more, or to use a small fused desiccant dryer to get the -40 Fahrenheit pressure dew point. Once you have your dryer set up, then you can choose, or you should see if you really need an oil-free system. Martin also talked about that last week. See it a lot in different applications and conversations with distributors and end users alike. Oil-free compressor doesn't mean you have oil-free air. Compressor takes in whatever is in the atmosphere, whatever comes in that. And I talked about the parking lot. Seen plants next to an airport, an interstate, next to shipyards. So those are all locations where I can go outside and take a deep breath and tell me there's no oil in there. Then okay, all right, but we would get those contaminations in our system, and we definitely don't want exhaust fumes from the highway or from the interstate in our yogurt or something. So.
Right. So interesting. I personally never thought of either of those. So now my world has been open to that
Yeah.
debate. Because most of the plants that I've been to are next to some
Yeah.
type of like area very close to highways or right off the highway. So they are in the middle of a beautiful pasture. Even you see their smokestacks coming out even and be like they're the ones actually doing it. So I can just imagine how that would affect production.
The location and the environment that is around the plant is actually often overlooked. So we also saw cases where you had a big bakery or like an industrial bakery or a brewery next door. So those yeasts that come out of their ambient, that can also end up in your system. So suddenly you have fungi, alcohols. If you work with yeast, that also produces alcohols that go into the air. So that can also end up in your system. So this is really important to take a look at what is actually around the plant that I'm currently looking at. Definitely.
Interesting. So I'm going to ask a question here that hopefully will help us segue. But just thinking, so this ambient air is being compressed in the system. How small? I know we're talking like we probably can't even see them with the human eye, right?
Right.
So I don't know, is like, can you show us something that would help visualize this a little bit better, just even for my own sake? Compressed air, these particulates are floating in the air, I'm even breathing them in.
Yeah.
So I think that'd be good for a quick visual on that.
Sure. Actually have a slide that shows that. You.
Yes, we can add. Here we go.
Perfect. Thank you. So this is a little bit about ambient air and what we would see in compressed air systems at contaminations end up in our system. So we get a lot of dirt particles. A lot of them are very small, right? When we talk about small, on the left side, we can see a gray circle. The gray circle is like a typical dust particle. So that has a diameter of 500 micron. Limit of visibility, like what we can see in that, like, is the blue dot on the left, and 1 micron. So talk about compressed air filtration, it's usually 5 micron, 1 micron, 0.01 micron. So 1 micron in comparison to the limit of visibility is the orange one and the gray one. So this is what we try to filter out. You can't see it with the eye. You can see it under a microscope. It's really small things, and we're talking about millions of particles that are in that spectrum. So this is the type of small scale contamination that we look for, that we try to get out. Just saw a question here.
Yes.
So that is actually very well related. We didn't coordinate that, but on the
So we can
left
put
side.
a question up here, read. And do you want to take this question now while we're here?
Sure.
Okay.
Microbes that exist that create scores. Yes, the particular filters are capable of catching those. So you say here about 0.8, 1.2, 2 micron. This is approximately the size of those spores, and there are actually filters. So filters will catch those, because a filter just but all the particles, and a microbe or a bacteria just is handled the same way. So it just catches onto the fibers that are in the filter media, and it will be kept in those this filter medium. The question is then, happens with those microbes, what happens with this bacteria? So it will cultivate there. That's actually, so in ISO 8573, we always talk about water, particles, and oil. And we always take also a fourth dimension in there. That is bacteria, that is microbes, that is this contamination, the contamination, you could say. So this is something that you don't want in your end product. So what we would recommend here, Maria, in this case, is sterile filter that you put on the point of use. And a sterile filter has a special filter element that can be sterilized in an autoclave system. So actually the bacteria, the fungi, the living cells, the living spores that you catch in your filter can be neutralized and can be washed out of the filter in a recurring fashion. So you just take that out, put it in a steam autoclave system once a week, and then you kill off those bacteria, and then it doesn't end up in your system. Great question. Thank you.
Yes, that was perfect. And you actually answered my question, because I just see all of these little spores and stuff adding up on the filter.
Yeah.
It was a great explanation there.
Perfect. Great. Can just go through the rest of the process. So we want oil-free air. We need to make sure that we all the oil that we get out of the compressor or that we get out of the ambient air, that we remove that. So we would recommend using an activated carbon tower, and the reason is that you can get aerosols and oil droplets you can filter out, because those are drops, those are of oil in the air, so you can coagulate them and you can them with a condensate with the but what you cannot filter out is oil vapor. So this is just vaporized oil, and you cannot filter that out. So use the activated carbon to actually absorb the vapor to the activated carbon, and by that remove it from compressed air. So we would recommend using an activated carbon tower. Activated carbon is also hygroscopic, so in that particular case, you would need a desiccant dryer just to protect your activated carbon for it to function properly. Right.
Perfect. And before you move on, we have another question here.
What is the difference in filtration? That's there. Okay, so properly used for breathing air systems. Well, yeah, air is a great topic. Breathing air is really important. Paint booths, sandblasting applications. You also have underground applications, for example, like sewer cleaning. You have underground mining. So those are situations where the worker, the laborer, is dependent on the air that comes in to be clean. And there are certain that cover that. There's Europe, the North American standard for that. And this focuses on contaminants. We have a great for that out on our webpage. I think that would our time frame here, but there's a great on that on our website that you can look at.
Perfect. After we're done here, maybe we can link that in the comments.
Yeah,
so people can see it there.
definitely.
Perfect. Thank you for the question. Yeah, we're already down. We have a little under 4 minutes. So
Sure, I'll get that done. Okay, so we covered the water, we covered the oil, we covered the bacteria. So you want to get your filters in. You don't want all of the contamination we saw before, 100 million dirt, very small ones. You don't want all of them to end up in one filter, and that clogs very quickly, and then you get excessive pressure drop, and you should replace those then pretty early. So you want to even that out, maybe between a 5 micron a very filter, 1 micron and a 0.01 micron, to even that filtration over the course of the filtration line. And then you want to make sure that you don't get any contamination at the end of your line, at your point of use. So you generate your air, treat your air centrally, and then you distribute it through your main header, through your drops. And you usually have those maintenance units, or those filter regulator lubricator units at the point of use to protect against any debris, any that might come in during the distribution. Next step of this approach, size the equipment correctly. So take your inlet temperature, ambient temperature, pressure, flow, and really size the equipment correctly. You don't want an undersized refrigerated, ruining your air quality in the peak summertime when it's hot and humid. So you really want to take that into account. And next step would be to add your accessory, what we would consider accessories. So you want your condensate to be drained off correctly. Maybe you want to increase the efficiency of your system, go for a zero loss drain. You want to treat that condensate that comes out of the system. So you need a condensate cleaner, get that system lined out, and then have your critical control points, what Martin also talked about. You want to check your pressure dew point before going into a critical application. You want to have to get in contact with the food, for example, or the beverage. You want to more quality that gets into contact with your final product. So this is what we would recommend. And then, of course, it doesn't stop. So you should, next step 5, plan your maintenance schedule. So every day, check on the equipment, check that everything is right. Maybe have a monitoring system in place that gives you an alarm when something is not right. And then have your weekly and monthly schedules and annual schedules right. Those filter elements need to be changed out. They are accumulating dirt. That's what they are for. That's their job. So you need to exchange them regularly. Dryers to be cleaned out, refrigerated dryers, the condensers need to be cleaned out regularly. Your dryers want some as well. So there's moving parts that might wear or that are wear parts. They need to be changed out over time. So that's the next step. And then you're actually good to go and you lined up your system perfectly.
Beautiful. I think that was perfect. That brings us right around to 20 minutes too. We can hang around for a second if there's any more questions.
Sure.
But then you can feel free to reach out to Mirko directly, and we can also share the website in the comments for if you have other questions moving forward. But we'll go ahead and wrap up this section. Thank you, everyone who has questions and everybody who tuned in. And of course, thank you, Mirko, for joining us today. It was very, very, and you made some very, very points. So hopefully some people can take that with them and go make sure they're doing their maintenance on their filters and dryers. Oh, we have one question. Let's see, before we tune out. In your view, what would be the ideal air quality?
That's a tough question because that definitely depends on your application. So the ideal compressed air treatment system focuses on the application and focuses on the needs of the application. If you have a food application and you're packing food and you use compressed air for that and the compressed air gets in contact, you really want to have a filtration system, I would say, at least go down to 0.01 micron. You want to have a desiccant dry. You want to have humidity removed because humidity is a breeding ground for this bacteria, for this fungi. So you want all of that done. You will have your oil-free systems. You could better use an activated carbon tower. And then you want to have a point of use sterile that can be sterilized, that catches any possible, and that can be sterilized. So it really depends if you have that or if you're running a car micron and a refrigerated dryer. There's no one size fits all for compressed air treatment.
Okay, perfect. Everyone knows how to get a hold of you now, so they can go into some more specifics with you to go over what their system would need. All right. Thank you, everybody. We will go ahead and wrap up, and we'll see you next Tuesday.